we just watched the dance. That shit was nice. And saw some lot of good dogs on the line.
Hello? Hello?
Hello, everyone.
Hello.
Hello. Are we waiting on anyone else? Anybody else?
Yes, I think Vanessa then joined it. But
Okay.
let me see. Let me see if she's coming. If not, we move on.
Okay.
Kofi also left.
Okay.
Please, she didn't pick up, so we could start.
Okay, sounds good. Just give me 1 second.
What's going on, guys?
Hey, how's everyone doing?
Pretty good.
All right. So does everyone have like their virtual machine up, their Linux box?
Yes.
Yes.
Just in case. Okay, cool. All right. So it'll be like the same user that we used last time, which was I think Tom that we're gonna be using. And I'm gonna share my screen really quick. And I'm gonna change to that user also.
Sorry, Professor, I just want to say, so today's my first official class.
Okay.
I did see that Tom was created. I'm not sure if there's any other directories under Tom, but I created my own user and did the homework under it. So is that going to be fine?
Yeah, that should be great because yeah, I think that's good because we didn't have any files, and if we did, we could just delete them to start from fresh. But today's mostly going to be about permissions and stuff
Okay.
like that. So I think it should be fine.
Okay.
If there is any
And-
issues, we can work through it and make sure that you're good to go.
And also with that, the homework we have some a bit. It's not like a difficulty because we're able to troubleshoot and get it right. But if we could run the homework again for everybody, because I think most of us we all face the same issues when we got to I think number 10 or 9.
Okay. All right.
So
I'll check that out right now.
yeah.
All
So if we
right.
could just start from scratch from that one.
Okay, we'll do that. Let me just open that up real quick. Okay, so where's the share screen? And then we'll do putty. I'll move that around. All right, and then I'm going to be opening the homework for the I think day 2 assignments. And you said number 9 and 10
Yes, I mean if we could just run
from the
through
beginning.
it.
Okay.
Yes,
All right,
so
we'll do that.
everybody could. Yeah.
We'll do that. All right, so if everyone has it open on day
Yes,
2
sir.
assignments. Okay, cool. So the first one is using the terminal, navigate to your home directory using the cd command. obviously if you're already there, all
Right.
you type in CD, you already, you get there. So let me see what I have here. Let me just delete this directory really quick.
Okay.
Just so I can just make sure that that everything is fresh. Okay. Okay, cool. All right, so the first one is create a new directory called my files using the make dir command. So
Right.
we're gonna go through each thing, that way we can try to see which step. Second one is navigate to my files directory using the cd command. And then create a new file called mytext.txt using the echo command. Add some text to the file using the redirection symbol to redirect some output. For example, echo, this is some text dot to my text. So we'll do that example there. My text with a capital T. Okay, use the ls command to confirm that the text, that text was created, which is number 5. Okay, and then create a new directory called my images using the make directory command. So all right, and then copy the my text file to the my images directory using the copy command. So let me clear the screen really quick. I'm gonna do ls. We see that we have my images, then we have my text.txt. So we'll do the copy command, copy my text.txt. And then we're going to copy it to my images. Okay, and then we can use the ls command on my images to make sure that it's actually there. Okay, it looks like it's there, which is number 7. So we complete number 7. And then number 8 is use the ls command to confirm that the my images directory now contains a copy of my text.txt. I think we just did that. We'll just double check this one. And we can see that there is a copy of my text.txt. And then we'll go to 9. This is the one that you're having issues with, right? Number 9, or there was some weird bug. Okay.
From
So
there going, I think.
okay.
I think it was number sorry, number 10, but we figured out that that issue may have came about the error probably started from like number 6 or 5, being under the assumption that you have to create the directory always from the home. So
Oh,
I
okay.
CD'd back out, but
I
reading
see.
the directions, we didn't need to go back to our home. We just needed to
No.
create the directory
Yes.
from there
Yeah,
and
that's
keep
my
From
fault.
where we currently were.
Yes.
yeah. So by
Yes.
the time we got to like this and like number 10, it was a bit confusing.
Sorry. You know what? I'm sorry. I'm just like the way the instructions was made, or the way it was outputted was just very like precise, like pretty much like
Mhm.
if almost like those riddles are like very like
Yeah.
straightforward and simple, but like you never think of it, you're like, oh wow, seriously, like what, so I should have put extra caveat on there, be like, hey, just FYI, just follow the instructions just as is. We're not going to create anything in the home folder. If you move somewhere else and then it tells you to check something while you're in that directory, and then it also tells you to create something, it's meaning that you're in that directory. But that's my fault for not. I should have put that in there, like to make it a little bit more, I guess, more friendly, or I guess a lot easier to take in. So that's definitely my fault.
No problem. Thank you.
So the same thing, yeah. So like example, like for number 8, I know that we already saw that we had the copy of my text at txt inside of my images directory. And then number 10 was actually number 9 was moving it. So I see what you're saying. So I think that was it, right? That was an issue. I think that was the bug, right? Did you want me to keep
Right,
moving on with
correct.
them?
No, after that I think we good. I mean, I could speak for myself, and I think
Okay.
Jeremy and I went over it. So I think if anybody else has any questions, I guess they could ask that. But I think we figured it out.
Okay. Yeah. Okay, cool. All right, so I'm going to clear this out for you guys. Then we're going to do CD to go back to the home folder, home directory. So today we'll be going over the permissions. So I have the assignments, but we'll also go over the permissions. So I'll explain it to you guys, try to make it a little bit more easier to understand. So we're going to go over permissions and also access control list. So the first thing we'll go over is before, let me see, access control, and then we're going to be doing the change mod. Okay, cool. All right. So the first thing we're going to talk about the ls-l command. And the reason I want to go over that is because this is where it starts explaining the permissions a little bit more in detail. And then I'll go over like the numbers and what they mean, and then also going over the symbolic meaning, which is like the RWX. And then also the type of file, which is the first character, but I will show you this in the examples. So the first command, anytime you ever run, let's see what would I have in my folder right now. Right now I have my files, so we'll use that as an example. But you can use the ls command, which lists the contents in the directory that you're currently in. If you don't have any arguments, so if I just type in an ls, it'll tell me the contents. It'll list the contents where I'm currently at. But if I did ls-dev, it'll list everything there because I'm being specific of where I want you to list stuff from. So if I list, if I do ls-l, the L stands for long listing. So this just gives you a longer form of the contents that you have in your current directory. So when I did ls here, as we can see, we have my files, but if I use this flag -l, it just makes it a longer formatted version, gives you more detail, more metadata per se. So we'll go over from the beginning of what it means. So the very first character that we have here, we can see that there's a D. So that D stands for directory. So we have D for directory, which I'll write them down here. It's a lot more easier, and I'll also put in our notes. And then if you ever see a little hyphen like this, it just means that it's a regular file. I don't want, you know what, let me take these little things. I don't want to get it confused. Any like extra symbolic stuff. So if you see the hyphen in that place right over here where the D is, it just means it's a regular file. And we're going to have some other ones, but they're not really important unless you're doing some other type of work. Like most people do not use this other types. It's good to know, but like I said, you might not be working with some of these things. So if you see a C, it just means it's a character file, which we'll go over that a little bit later. And then if you see a S, it means it's a socket, which is like more about networking kind of stuff. It's like a networking type of file. And then I think we have character. And then we also, I think that's it. I think there might be another one, but I don't think it's that important. But the main two ones that we're looking at is directory and regular files, because this is the most common ones that you're going to see. Oh yeah, we also have one for block, which is for like block devices, like hard drives and things like that. That just B stands for block. That's just for your information, so you guys know. But like I said, the main ones that everyone uses will be these two ones. Will be the D for directory and the dash for regular files, which shows up here. And I will add this into our notes. Also, I think I didn't add that, but I will add that in there. And then if we can see here, if I make an empty file, you guys, so if I made like one called file.txt, and if I did ls-l on this directory, you can see that little dash there, the little hyphen. I think it's called a tack. Also, there's another word, I guess. I think it's tack. But if you see this tack or hyphen here, it just means that it's a regular file. And then if you see the D, it means a directory. There's another command that you can use also to see what type of file it is. So you can use this file command. Like I said, this file command, what this does, it just tells you the type of file that that it is. Because someone could put an extension like .txt or .pdf. It might not be a PDF. It might be something else. But the file command pretty much reads the headers or the metadata in the file, and it's able to tell you what kind of file it is. So if you use a file command on file.txt in this example, you can see that it says it's empty. And the reason why I say that is because this is just a file, but there's nothing in there. It's empty. There's no like characters, like there's no words in it, like hello or hello world or my name is or whatever you want to put in here. But if we do add anything inside of it, it'll actually tell you ASCII characters. And that's, so ASCII is the standard, what you use, like the characters that you see, like the F and the I and all these letters, they're just ASCII format. So if you ever see file.txt and then it says empty, it just means that there's nothing in there. There's no text and there's nothing that inside of that file. And if I do the same thing on my files, we can see that it says directory. So it tells you that it's an actual directory in there. And for example, if I use this file command again for /bin, and I use it on the ls command, let me just clear my screen really quick. If I use it on the ls command, it just tells you it's an executable. That's it. So that command is handy, but I wanted to let you know if you wanted to get more details on that, if you don't run the ls-l that way. So the main two things is that the dash is the regular file and the D is a directory. And the first three permissions that we're going to go over is pretty much like the owner of the file. So the person who created this file. So we have the owner, and then we have the group, and then we have others. So anyone else that's trying to access this file. If you ever see a plus over here, like, so this one just means the standard permissions. You see the little period. If you see a little plus sign like this, it just means that it has a special permissions on it, like access control list. And we'll go over in a little bit of why people use access control list. If we already have permissions, why do we use access control list? We'll go over that and I'll explain that also in detail so you know the difference. So going back to the first three. So all you have to know is that when you see the R, it just stands for read permission. So this allows you to actually read the file. So like if you want to open the file, it allows you to read it. And then if you see W, it stands for write. So that's you're able to modify the file and actually like type things in it. So like if there's like a Word file and you had read and write permissions, that means that you can read the contents and you can modify it, like change things around and save it. And then we have X. This is for executing. So this lets you execute the file. So if there's like a script or something that's that you want to run, or some type of binary or something, the X allows you to execute the file. So it allows you to play the script or whatever there is in that case. So these three universal ones, like I said, is read, and then we have write, and then we have execute. So just by looking at this right now, we can see that the owner of the file has read and write. And then if you see this dash here, so not to confuse you, the first one here has a different meaning from this. This just means that there's no permission. Like if you see these blinks over here, like these little like tags over here, it just means that there's no permission set. Like they don't have any write or execute permission. Over here, if you see the tag, it just means the regular file. So you don't want to get this mixed up. This is a different meaning in this instance over here. So if you look at the bottom one, same thing. You have the first one, it says the directory. The first set of permissions over here, it just says they have the owner of the file has read, write, and execute permissions. So they can do anything they want with it. And then the group is read, write, and execute. That means that they can read it, write, and execute it. And then anybody else. So like if you're not in the group, or if you're not the owner of the file, that means that you can still read it and you can still execute it. All right. And then the next one, these are how many, this is not really that important, but this just stands for how many links there are to this file. And then the next one is the owner of the file. So the owner of the file is Tom. And then the group is Tom. So usually when you make users, users will always have their own group. And obviously this is the owner of the file, and this is the group, which is in Tom. And then the second one is how big the file is. So you see this has 0 kilobytes or bytes, 0 bytes, because as you can see here, that there's nothing inside of it. There's no text, there's no nothing. And then the directory by itself has about 40 bytes. And then when you see this date right here, it just tells you the last time the file was modified. So the last time somebody was like got inside the file and made a change, this is what this means. The last time the file was modified. And the last part is the actual name of the file that you're looking at. So in this instance, is a directory is a different color. Like I said, different distributions might have slightly different colors, and also it depends on like your terminal and other settings that you might have on there. colors might be different. Mine's orange because I think the this putty that I'm using, I guess it had an orange, some default orange thing that I set up. Sorry about that. And that's the reason that it shows you that right there. So going more into permissions. So the first ones that were talked about, right, was read, write, and X. This is the symbolic ones. So symbolic just means like it's a symbol that represents, technically these symbols are representing numbers. So anytime you're setting permissions in Linux, it's always 3 fields, right? So remember the first 3 fields is owner, the owner of the file, the group, and everyone else, and everybody else that can see the file. So if there's no read, there's no write, there's no execute, they're not able to do anything with that file specifically. So remember, this is for other, this is for group, and then this is for the owner. And then to represent this same exact permissions and numbers. So don't mind this. I just put this to separate the two. So like this has no meaning. This is just for showing you guys to break it in half, so that way you guys can see 2 different areas and doesn't confuse you. So if I wanted to do the same thing in number form, right? I will do 777, but I'll tell you why. So the reason why I'll do 777 is because the first 7 will be for the owner, the second 7 will be for the group, and the third 7 will be others. And the reason why I picked 7 is because for the numerical representation, 4 stands for read, and 2 stands for write, and then 1 stands for execute. And if you add all of these up, so if you add read, write, and execute, you add 4, 2, 1, and that equals the first one, 7. And then the second one, meaning that the actual group has read, write, and execute, you're going to add 4, you're going to add 2, and you're going to add 1. And then you get 7 again, because 4 is for read, 2 is for write, and 1 is for execute. Does that make any sense to anyone, or is there any questions at all at this part before we move on for more examples and some more use cases?
Yeah, so these numbers are set in stone. So read 4.
Yes.
Right? Right?
Yes.
Is 2. And
Yep.
execute is 1.
Yes.
Okay.
Yes. So like I'm gonna let me exit out here, leave that there as an example. So for example, if we do ls-l, as we can see here, so for read and write, if I wanted to do read and write, so you always have, so when you're setting the permissions, you always have these 3, unless like, there's other ways to do it, but like just for instance, for now, the way you want to look at it is that when you're setting the permissions, you're going to have these 3 numbers for the file because you're setting the 3 values, right? You can be specific and set one of the values, but that's a different case. But normally when we're looking at these numbers, 777, right? You won't see it here because it shows you the symbolic representation. But these are set in stone, like you were saying. 4 is for read, 2 is for write, 1 is for execute. So if you do read and write here, and then read and write here, and only read here, the way you would do it is the first number is read, we get 4. The second one is write, we get 2. So that would be 6. And then this one will be 4, which is read. 2 is write. So we add those together, 6. And then since this is blank, it's 0. So if you add 0, the number is not going to change. So it's 0 because there's no value to it. So it's still 0. So it's not adding anything to it. Then if we have read here, it's 4. So this permission right here is equal to 664. So I'm going to give you an example. If I change mod, this is I will go over this command. We'll do it together in a second, but I just want to show you really quick before we go on to following along. The change mod command, all it does is just changes the permissions of a file. So if we go here and we did 664 on my file, actually, sorry, on file.txt. If we do ls-l, as you can see, it hasn't changed at all. because I'm just reestablishing the same exact commands on it, the same exact thing. So 664 is exactly the same, makes no difference, right? So let me just exit out here, -L, and we can see here for that command that we use. Let's say if we wanted to do read, write, execute, and then execute
So
only. Yes, go ahead.
so for example, if you did chmod 666, what will be the outcome?
So the outcome should be read, write, read, write, read, write. So
Okay.
yep, because we're
So
adding. Yep, go ahead.
so in this case, it has changed the file.
Yes, yes, it has.
Oh.
Yes. So if we do, so for read write, remember 4 equals read, and then 2 equals write. So all we're doing is adding these two numbers, and symbolically it means 6, and then 6, and then 6.
Right.
Yep. And let's say if I wanted to do like, let's say I want to do 111. Let's say this is not standard practice, but let's say we did 111, right? You can see is execute, 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 because one stands for execute.
Right.
So you're just pretty much adding numbers together. So the symbolic version and then the numerical version.
And this is allowing giving permissions to whoever is using it, right? Whether to
Yes.
read, write, or execute. Okay.
Yes, this is just changing the permissions of the file of who's allowed to read, write, and execute on here. So
Okay.
yes, that's what essentially is doing. Obviously, this is not going to be a standard practice. I'm not sure, but like yeah, that just changes it. These are standard permissions. So these are called. So there's different types of permissions, but we don't have to go over everything. But in Linux, it's pretty much to the discretion of the system administrator or whatever policies there is. So these permissions are pretty much more discretionary. You know, it's like up to like, okay, like who should have permission, who shouldn't. And then that's what we have access control list, but we'll talk about that in a minute. So I'll just go over the reviews really quick. So I'm gonna do something really quick. I'm gonna show you some numbers, and I'm gonna ask you. Actually, you know what? Let me better yet. I'm gonna write something down for permission wise, and tell me how you represented the numbers. So if you saw this on a file, how would you represent this in number form? So if we did, let me do text, and then file one.txt. So let's say I run the ls command, and we saw this for the owner, for the group, and for others. How would you translate this into a numerical form?
641.
Correct. Yep, it's 641. So if we exit out of this, and then if I did the same command, you said 641, and we did it on that, and then we did ls-l, do the same exact one, as you can see here. Rewrite, read, and execute. Great job.
Thanks.
Does anyone have any questions about being able to read the permissions on files or directories?
And Prof, I know some people don't like to talk in this class, so you have to put them under the sword, call them out, and I ask them to answer some of these questions so that everybody fully participate.
Okay, yeah, no problem. Go ahead.
No questions.
Okay. Nana, any questions at all?
None at all.
Okay. All right, cool. All right, the next example, I guess I'll pick on somebody, and that way we can just rotate for the examples just to try to help everyone and get a clear understanding. Okay, so so now that we talked about permissions, we talked about the numerical versions of it, and also the symbolic versions. So remember, the symbolic are just the letters, and numerical or all the numbers and stuff. So when we're changing permissions, if you guys want to follow along, we can do it together right now. So let me just delete everything in my directory really quick. Let's do my files, and then All right, when everyone, just take your time. When everyone's ready, let's go to our home folder where Tom is, so we can start setting some of these permissions and working together on it.
Sorry, before we go, I have a few things under mines. I have a directory and a file. Should I clear those out or no?
Yeah, you can delete them. Yeah, just to make it
Okay.
easier for you.
All right,
Yeah.
thank you.
Yep. If
And
there's
to
any,
do that is
yep,
to
go
do
ahead.
that is remove dash R. Or do I have to include something else?
Yeah, that's fine. I usually do that if there's anything inside of there. You can just do it that way too.
Dash F.
Oh yeah, if you use that one, it just you're just kind of yeah, you're just forcing it to be deleted. But yeah, you can do
But
RM-R. Yep.
so which one is it? Because when I did that, the stuff is still in there. So remove.
Try this RM dash try this RM this. There's nothing in there, but you could do you can put a little star in there. RM dash R star. You can do that too. It'll delete everything where you currently are at.
Right. Okay.
Yep. And this is just a regex. We'll go over that later on. This is just regex, but basically, like, basically the shell is able to interpret this as a special meaning that means everything in your directory. So that's what that means if you guys are just curious. So okay, were you able to delete everything?
Yes, sir.
Yes.
Nice,
Yeah.
nice. Awesome. All right, so let me open this up real quick. Okay, so remember how we went over symbolic meanings about like the numbers and the actual permissions, numbers and the symbolic version. So when we're using this chmod command, it'll be the same exact thing. So the first thing we're going to do is we're going to make a file. We're going to touch a file called file.txt. Just an empty file called file.txt. And once everyone's ready, let me know. We can move on to the next step.
Ready.
Nice.
Good.
Okay.
Ready.
Okay. All right, so everyone's ready. So let's see. Okay, so now that we touch this file, we can use the ls-l. And if somebody could explain the permissions on here, like what permissions are in it, and if you guys can translate into a symbolic form. So like after you do ls-l, if you can just tell me what this correlates to in number terms. Is it a 777? Is it a 1111? Is it a 444? Like how would you translate these three values into numbers? Anybody else? Yep, go ahead.
I'm sorry, I could try.
Yeah, okay.
So I know it's a file, and the permissions, the owner has the capabilities to read and write.
Yes.
The group can also read and write,
Yes.
and everyone else can just read.
Correct.
That will be 6, 6, and 4. 664.
Yes, correct. Perfect. Great job. Yeah, that's what it is. So if we wanted to change this, if you want, okay, so remember how I was telling you about how you could be more specific before, like right now we're doing it in groups like 666 or 777, we're doing it in 3. So the chmod command allows you to change one field. So if I wanted to change the owner to have all these fields on, you guys would just type in chmod, right? And then type in U for the user. This is where it gets a little confusing because for the chmod command, the O stands for others, not for owner. So for here, the owner of the file is actually the user. So just for reference, and for the chmod command specifically, U stands for the owner, which is the first field. So when you're using this command, right, before we execute anything, you have three values, right, that you have on the left-hand side, which is U, G, and O. The U stands for user, the G stands for group, and the O stands for others. And then on the right side of the command, you have read, write, and execute. You guys already know what that is, so that's not too hard. So the reason you would want to use this command is because you want to be specific of what you want to do, right? If you want to add a permission is a plus, and if you want to minus a permission is minus. So if everyone wants to try this out, we can type in, so make sure you have ls-l so you can see the visual representation on top of you, so you can see like the actual changes to the file as we go along.
So the change mod, what does it stand for? Like what is it? I know we didn't really.
Oh, so basically just stands for like, it's basically change modification, like changing the actual mode of the file, the actual permissions of the file.
Okay.
Can you repeat that, please, for the change mod?
So change mod is like change mode. So pretty much change the mode bits. So change the bits of the file. So these are called modes. I don't know why it's called mode, but it's mode bits. It's kind of weird. Never really looked into why they call it mode, but pretty much they're just changing the bits of the mode. So you see these are bits, and then this is the mode of the bit. So the modes, the little different modes like R, W, and X.
Okay.
Yeah. Some of the stuff is like old jargon, old, language type of stuff that it's not really common to be using. For me, it should be called like change perm or something, change perm, change permission.
Sorry, can you quickly just go over the last part where you said if you wanted to remove that permission, you put the dash after the symbol?
Yeah, I'm going to show you right here. So if you guys want to follow along really quick, so change mod, like I said, the change mod, just to make it easier, it just change file permissions. Just look at it like change the mode. They call it change mode, but mode basically is like for the permissions of it. So whenever everyone's ready, we can type in the commands and I can tell you the pretense of it.
Ready.
Okay. Anybody else?
Yep.
Yep.
All set.
Okay. All right. So the way we'll do this one is, let's say we want to change the user. Right now they have read and write, and this is by default. This can be changed, FY, in the future when we go over the masking stuff. But right now, like I said, this is the default permission. So when you make this file, basically the kernel by default will literally make it just like this, because this is the default value of it, right? So if you want to change the owner of the file, we're going to use U in this instance. And let's say that we want to add an execute bit. We want him to be able to execute, right? So we can do plus, which is adding, like you're adding to the bits. And then you add X, because you're adding an execute bit. And then whenever you're ready, let me know.
So you add in the owner plus the other.
Say it again. So we'll do U plus X. So the owner, yes.
And the X stands for the executioner, or?
Yes, execution. Yep.
Okay, execution. So you want the owner to execute?
Yeah. Yes.
Okay. Done.
Okay.
Yeah, all set.
Okay. So when we enter that, everyone can type in ls-l, and we can see that the owner has execute permissions.
So basically, this kind of helps you just modify just one section of that three groups.
Yes. Yes.
Actually.
Yep.
Okay.
So basically, yeah, it just allows you to change specific modes of it. So that's why. So if you think about change mode, think about it like all of these have different modes, like different bits that you can change. And the file mode consists of three parts. So think about user, group, and other. So pretty much the user, as you know, refers to the owner of the file, the group refers to the group, and everyone else is on the last part. So, and the other thing is to just think about each part of this, like as you can see, each part. So each part of the file mode consists of 3 bits, which can be set 1 or 0, as you know, well, we're talking about like old school terminology, but just think about the file mode. Each one has a file mode. So each one can be read, write, it can be execute. So when you think about mode, that's what in Linux terminology they're allowing, is that there's different bits, like read is a bit, write is a bit, executes a bit. So right here, you're changing the mode of the file because you're changing the user mode and you're turning on the execute bit. You're turning it on. And if you guys use the directional pad and you move it up 2 times, you guys can go back and then add a minus there so we can take it out. And just let me know when you guys do that. You guys can go up with your keyboard and you're able to go back to a command that you previously put in. And then you can scroll to the middle of it and then delete that plus because you're adding. And then we're going to put the minus because we're taking away.
Wow.
Okay.
That makes it so easy. Okay. So then we hit enter.
Yep, you can hit enter and then you can hit ls-l and you can see the output. It should have deleted the output.
So always to list the stuff that you wrote before, you just use the up key and then it will just bring everything.
Yes. And that, yep. So did everyone get the expected results of minusing that permission for that user or owner?
Yes.
Okay.
Yep. So we're back to 664.
Yes.
Mm.
All right. And then you guys can type in use Control L. So if you hold Control L, it can clear your screen. Also, you can either type clear or use Control L. I'm not sure if I already told you that, but if I did, awesome. If I didn't, okay. This is easier. It's a shortcut. Control L will just clear your screen for you. And then also the other thing is, remember, since you were interested about scrolling up, you can also use your history command. And this will also tell you the commands that you typed in. Like this is like more like administration stuff. Like you want to see like what this guy typed in. Why is the system messed up? What did he type in before it crashed? You know, you can look at the command history. Yeah, you can look at the command history. So it's pretty cool.
And what did you type? Just history?
Yeah, just type in history. Yeah, this is pretty much common. Oh yeah, one thing I can teach you guys is bash completion. So most of the shells have this capability. So just type in HIS and then double press the tab button. It should just complete it for you. So the double tab helps a lot. When you're trying to like, basically it's auto completion. It tries to be educated and try to see like what you're going to type in. The more characters you put, the better. But like the double tab definitely helps trying to, I guess, autocomplete stuff for you.
Okay.
You know what? Let me put on the day 3. I'm going to add this on the bottom about the mode bits and stuff. Okay, cool. Okay.
And also,
yes,
not to take you back, but
no
the video of the class, we weren't able to play the last one.
Okay. Yeah, I had it on there. I'm checking it right now.
It just had this bicycle. I don't know if anybody else was able to play it.
It has a bicycle?
Yeah.
Yeah, it wasn't working.
Okay. Sorry about that. I thought it should be working. I put copy link. Share anyone with this link can. Let's see. All right. You know what? Maybe I put a password on there. I think I put the password in the group, but let me just take the password off of that. Okay, so let me put this in the chat real quick. So this should be the actual link to the file. Interesting. Okay. I'm gonna if you guys want to just double tap it real quick and see if it works, I'm put in the team chat.
Okay.
Where's the team chat? Team chat. Come. One moment. Okay, so chat. Let's try this.
It seems to be working now, but it wasn't working before.
Okay, I took off the password.
Okay.
Yeah, because I think I put a password and then I put it in the group. I put a password in there too. Yeah, that's my bad. I just put that there just in case someone like try to, I guess, outside the group somehow get access to it and
Right.
download it. So
But
that's the reason I put the password on there.
I mean, if you could still put the password on and it will work and we have access to it, then that would be cool. But
Yeah. I guess the feature is not good. I'm using OneDrive for the video upload.
Oh, okay.
Okay, so let me look at the syllabus. Okay. So we're going to go over the special permissions. So okay, since you guys already know the foundations, I know we're going a little bit quickly, but this is just the last bit of the permissions other than the ACLs. If you get over this, then pretty much you can have a very solid understanding before getting into the homework. So let me go back up so I can, 1 second. Where is it? Okay, so we're going to go over 3 permissions, additional permissions, which, okay, typically when you do ls-l, right? Let me try to feel how I can word this. That way I can be less confusing. Okay, so when we see these permissions, correct, you only see 3 fields for each one, right? So for the SUID, it's an extra permission bit, but I'm gonna explain the 3 bits, and then I'm going to explain how they look on here, and then also explain the numerical, and then also the reasoning of why we use them. So these 3 bits, they're called the set UID bit, and then we have the set GID bit, and then we have the sticky bit. Okay, so these bits, they relate to, so the set UID bit relates to the first part of the actual permissions, and then the set GID bit stands for this one, and then sticky bit is usually set in the others. And the reason they did it this way is because not to add an extra field. All they're doing, they're adding a different letter. So instead of X, you will see a S. And I'll show you some examples of how it looks in a little bit. So let me explain these really quick. Okay, so the set UID bit, it allows a user to execute a file with the permissions of the file's owner. So sometimes there's certain commands a system administrator is using, or maybe a privileged user is using, and sometimes you need the permission of the owner. Like there's some commands that you have to run it as root, because if you're not root, you're not able to get access to some of the things that the command is trying to do. So that's the reason why you'll use the set UID bit. Basically, it allows you to run the script like the owner of the file, or the person who, the user who has the permissions of it, or who's the owner of it. And then the set GID bit, so allows a user to execute a file with permission to the file group. So what this means is that when you have this one set inside of a directory, right, it basically runs with the permissions of the group. As you can see, this is the name of the group. And if you have this bit on, that means if somebody's running this file, you don't even have to be part of the group, but it allows you to be run with the same permissions as the group. And then the sticky bit, I spelled that one incorrectly for sure. So the sticky bit, all this allows you to do, example, like there's a directory for temporary files. And sometimes there's a lot of temporary files being generated from different users. So the good thing about the sticky bit, it doesn't allow people to delete each other's files. So let's say if you were part of an administrator group, and if you didn't have the sticky bit on the actual directory, that means anybody can delete your file that has read, write, and execute permissions in that directory. They can do anything to it pretty much. So the sticky bit enabled on that directory just allows you not to be able to delete other people's files or directories or anything in that directory that you have in there. And then the set GID bit. So what that does, it lets you run with the permissions of the group. So you don't have to be part of the group in order for that to work. And then same thing with the set UID bit. With the set UID bit, when you run the file, it runs with the permission of the actual owner of the file.
So with that said, the sticky bit, only the owner or root user can delete.
Yes,
Okay.
correct.
Prof.
Yep.
Could you go over it again for me, please?
Okay, yeah, no worries. All right, so the set UID bit, this is on. I'll show you how it looks like, but we're just gonna go over the concepts. The set UID bit pertains to this field. The set GID bit stands for this field, and then the sticky bit stands for the last field. So the first field, which is the set UID bit, it just allows anyone running the script or running whatever is here as the owner of the file. So if the owner was root, and if you ran that, let's say that script or binary or whatever it was, you'll run it as root temporarily, just for the execution of that command. Once it's done, it goes back to normal. The set GID bit, there's another use case for it, but I just want to go over the general use case for it, is that when you run a file, you run it with the permissions of the group, And then the sticky bit, if this is enabled, no one's allowed to delete your file. Like other people with the same privilege level cannot delete it. If you're obviously root, you can delete it. Pretty much you're the master and you can do anything you want on there. Like you can just delete stuff and delete and move stuff around. And then with the sticky bit, just doesn't allow you to delete other files that doesn't belong to you. So you only can delete your own pretty much in a sense.
Got it.
Okay. Yeah, but let me show you a use case of the set UID bit, you guys. Let's try to see of them. I want to show you guys at least one example. Okay, I'm not there, so we'll check in the bin folder actually. Oh yeah, it looks like it's a link. Okay, there it is. So you see this one? So this command, this one looks like it's the execution bit. This is the link. Let's look for S. Let's see if we see any of them here. I found one. I just found one right now. Okay, so it looks like the mount command. So you see this, right? So if you guys can see this one, so anytime you run the mount command, you run it as a root user. So as you see the little S, you see the S here. So this means that the set UID bit is enabled. So if it's a lowercase s in its place, it means that the execute bit is behind it. So technically is rewrite execute plus the set UID bit. If the S is a capital S, like a really big S, like you'll see like it's like really huge, that means that it only has the set UID bit and it has no execute bit. So the lowercase s's, that means that there's an execute bit with it also. If it's a capital S, that means that it doesn't have an execute bit behind it. But this is an example of how it looks for a set UID bit with RWS. So if somebody wants to run this command, they have to run it as the root user with the same permission as the root user.
So quick question, because I think I'm a little confused with that one. So what would you say the benefits of that would be?
So the benefits with that are being able to run that is that like by you, so there's certain scripts that are being ran, like say like for a regular user, right? So when you're running it as a root user, you're inherently just using the permissions of the root user without being able to be root. So instead of you like becoming the root user and having to be able to run any command you want, they just allow you to run certain commands that root is allowed to run without you becoming root. So pretty much more like a security thing. Like, hey, like, you know, we want you to be able to run this command, but we don't want you to become the root user. We don't want you to have those privileges. So we're gonna
like elevate. I got you what you mean. So
Yeah.
basically, you don't have to be on the sudoers list. I mean, I know we probably haven't gotten there, but
Yeah.
you don't have to be on that list, but you should be able to run that command still.
Yes.
Got you.
It's like a temporary thing. It's just a security thing. It's like let's say like you work in a building in a very like in a government building, and let's say that there's certain areas you can access, right? Instead of you giving you a master key card for the whole section, they just give you a temporary pass for like 3 hours to allows you in and out or something in like one certain room or like in one certain section or something like that. It's almost like a temporary access, just a temporary thing, pretty much.
And then once it's set on the file, basically, let's say all of us in this group can basically run that command without having to request for special privileges, basically.
Yes, correct.
Okay, makes sense now.
Yep. Or the person who's the owner too. Like let's say somebody made a script and they want other people in the organization to be able to run it with the same permissions as him. Because what if the script is referencing things in his directory or referencing things that only he can access? So when the people are running it is giving the permission of the owner. So the owner of let's say the owner of the script, what if he's referencing a database that he has in his home folder that's only accessible to him? So that command is going to be running it like him, be able to access his own database that no one else can access temporarily, just for the sake of the command.
Gotcha. Yeah, I think it makes a lot more sense now. Thank you.
Yep, no problem. And then, yep, go ahead.
And Prof, for your hiccups, drink some water. It'll get better.
Yeah, thank you, man. I've been having hiccups all day. Oh,
Yeah.
man. It's like the worst.
I feel like there's a bug going around.
Oh man, yes. It's just the worst. I wish I can have like an AI filter and just like every time it hears a hiccups, it just like doesn't, it just like records it with blank noise, like nothing. You know.
Now, water works. Cool water.
Yes, I'm gonna get some water in a bit.
Yeah. Okay, Dr. Baffle.
Oh man. So, and then the next permission we're going to talk about, so set UID, you guys get that one. So I'm kind of explaining the permissions, and then I'm going to show you how it looks like. That way you guys can see, like, you know, because if I'm showing it to you, you might be like, yo, what is this? I want to be able to explain it. So when you see it, you already know what it does or have some type of like understanding of how what it does and stuff. So remember the set GID bit is the same thing, but it gives you the permission of the group. So it's executed with the permission of the group owning the file and not with the permissions of the group of the user executing it. So example, let's say my name is Maria. And let's say Maria she's part of the sysadmin group, right? And let's say Maria wants to run a script, right? And this script .sh is owned by let's say by the developer, right? Developers group. So if she ran this, she tried to run this, right? The script wouldn't work because the developer has some permissions that this script needs in order to run. So the set GID bit allows Maria to run this script as if she was part of the developers group, even though she isn't. So the same concept with the set UID bit is the same thing with the set GID bit. Does that make any sense?
Got it. Yeah.
Yes.
So as long as Maria is part of, I think I'm getting it, but I think I'm lost with it.
No, I'm explaining. So as long as Maria, as long as the set GID bit is enabled, it allows Maria to run the script as if she was part of the developers group only for those 2 seconds that the script runs.
Got you. Okay, I think I got it now.
Yeah, it's only temporarily. So like when she runs the script, it's running it like she's part of the developers group, even though she's not.
Gotcha. Okay. So whatever rights the developers group have, or whoever is in that group, I think I'm
Oh,
still.
oh no, it's fine. So whoever's in the group will just be able to run it normally.
Uh-huh.
Like, yeah. So like, if the script is run with the set GID bit, it wouldn't make a difference for the people who have it. This is just allowing other people who are not part of the developers group to run the script.
Got you. Okay.
And that is just for temporary, like you said,
Temporarily.
for a couple seconds. Yeah.
Yep, temporarily. That's only temporarily.
So,
Yes.
so once you set it, is it something that automatically deactivates once you log out the session, or does it? Do you have to come back and like disable it?
So that bit is always turned on. So unless like the administrator disables it or the group disables it or changes it, whoever has the authority or permissions to be able to change it. But no, a lot of these things are just open because they don't want people to be part of the developers group and have access to the developers like files and directories. So they allow people to run it as a developers group. That way they can run the file. And those scripts are basically made safe because the script is maybe just reading. Maybe it's not writing anything. Maybe it's just reading stuff, from a database or something.
So for all intensive purposes, you can run it, but you can't make any changes in it.
No. Well, unless like you give permissions to everyone else, then that's a different story. But usually you don't have to give people permissions to read it or write it. You can just give permissions to like run the script as the group user. So like, for example, let's say if it was read, write, execute, and then the group had read, write, execute, and everyone else had nothing. And if the SGID bit was ran and you ran that script, you're going to get the permissions of the group user temporarily to be able to run it. But you're not going to be able to write it because the script is not writing anything. Like what I'm saying is that the script is just script, and it's not like it doesn't let you do anything else to it. And if you want to change the script, you won't be able to because you don't have the permission to do it.
But you're part of the others, basically.
Yeah. So like if I wanted to, let's say if I wanted to open up the script and change it, it will say, hey, sorry, bud, you don't have any permissions. But if I want to run the script as the group user, I will be able to, but I want to be able to modify it. I'll be able to run the command, and the command will have the permissions that it needs. Like if it has the right permission, what if it has the right to grab data or something, but you're not like able to change it yourself. You're just running the script pretty much with the permissions of the group user, pretty much like that.
Gotcha. Okay. I think I get it now.
Yeah.
So what on the user side, right? Because it's two different commands, is the user and the group. Why can't you just maybe use just the user? Because it basically kind of grants you the same, right? It gives everybody access to kind of execute that file. So what will be the scenario where you will have to differentiate just giving just the group that access, and another scenario where you would just give the user just that access? Why not just maybe just use one? Because they kind of do the same thing, don't they?
They're very similar. So most of the time, set UID bit is used by like root, usually like root binaries. Most of the time, like scripts ran by root, and the group one is usually used for like people who are part of a group. So let's say you're part of the developers group, right? And the reason why you wouldn't put it under there, because what if you need other people to modify the files, like other people on your team to be able to update the scripts or do things to it? That would be the reason why, because you would have multiple people part of that domain or part of that part of that system. You know what I mean? So you would just put it under the group instead of the user, because you wouldn't want one user to have only access to it, unless it's just usually for a group setting. You usually have it for groups, and then the set UID is usually made is if like for root users, or maybe a one case where someone makes a script and they're the owner and the maintainer of it for the company, and maybe people use their script. That's pretty much it. But the GID, like I said, is usually just used for like people who are in groups who have scripts, who have things, and then other people in their team, they're allowed to modify it. They won't have to ask for permission. Like it will, because they're part of the same team, pretty much. Like we're all part of the same team. We're all able to access it, change it, modify it, and then other teams can use our scripts.
Okay, I think it makes a lot of sense now. Thank you.
Yes. And the other thing, the set GID bit does. So if I have a folder called admin, right? And let's say this is my folder, right? Any file that I make inside this folder, it will inherit the permissions of the group. Pretty much, it'll belong to the group. So, like example, if I made something called file.txt, right? Instead of being Tom's file now, it will be part of the admin group. So, in addition to running it as the group, running a file as with the permission of the group, any file that's made in their directory becomes the group becomes the owner of it, or like basically you're the person who made that file is not the owner of that owner of it in terms of the group. That means, like, let me give you an example. Sorry, just a little bit too many group words involved. I'll show you an example really quick. So let me make a directory really quick. I'm going to call it the admin directory. And then if I do ls-l, we can see the admin group is part of Tom, right? Okay, you know what? I think we'll go over it. We'll go over it together in a little bit because we're going to do some commands that you haven't went over. So let me just delete this real quick. We'll go over that in this next one, just because I don't want to get too much off topic because there's a couple commands that I haven't shown you. And if I show you, it might defeat the purpose because then the commands haven't been explained. But pretty much all I'm saying is that if there's a folder here, right? And if I do ls-l here, so as you see, this is Tom, right? So if I made a file1.txt inside the folder of the admin group, instead of me becoming Tom becoming the group owner, it'll be admin.
Got you.
So that's it. So any file made in a directory, it'll just, and basically the group will inherit it. It'll be their file now. It wouldn't be Tom's file. It'll be the group's file.
And
so
then
this,
in the event where you take the UID off or the GID off, it will go back to the owner of it, or it will still stay the owner of the
it'll still stay the same. It only applies for any new files that are made.
new files. Got you. Okay, perfect. All right.
Yeah, it's like you load something on a web page and something's changed. Unless it's dynamically loaded, you would have to refresh the page to see the change.
Got you.
Yeah, because then it'll pull for the new data or the new permission sets or whatever. Okay, and now since we talked about the three and the sticky bit, that one's pretty simple. You can't delete other people's file in the directory or unless you're root. But you can't, like if Tom made a file and then Sally made a file, Tom can't delete Sally's file. Only root can, or whoever has the permissions to. So pretty much it just defeats. It just basically helps people from trying to delete other people's files by accident. Like what if they deleted the whole directory by accident? And if they did delete it, they only be able to delete their own files, not other people's. So when we're talking about the set UID, set GID, and then the sticky bit, all we're talking about is the numbers in the beginning. So we have rewrite execute, and then rewrite execute, and then rewrite execute. Usually we see 777, right? So now there's an extra number in the front of it, which is the same amount of bits. So the 4 stands for the set UID. The 2 stands for set GID, and then the 1 stands for sticky bit. So if on this file I want to do rewrite execute, rewrite execute, rewrite execute, there will be 777, right? And let's say I want to set the set UID bit, right? I would just put a 4 in front of it. If I want to enable the set GID and the set UID, I'll put 6. If I want to enable the set UID, set GID, and sticky bit, I'll put 7. So let's say right now, I just want the sticky bit on it. I'll put 1. So let me Control C this really quick. And I'm going to put this as where it belongs. That's where you're going to put the number in here, or this is where it belongs in this case. So let me exit, and I'll show you the example really quick. So we're going to do change mod, and we're going to do 1777 on file 1. And remember, 1 stands for sticky bit. So if we do that, and remember, since this doesn't have an execute bit, it'll be a capital S. So if we do ls-l, actually, I'm sorry, it should be a T. My bad. I forgot about the sticky bit. It's a T. The other one should be S's. So if you see a T here, you see the lowercase t, it'll be the text. So let's see if we add the actual, actually, I did 777. That's why there is an execute bit. So let me take the execute bit out of it. So it'll be 1776. So remember, 6 is read and it's write. And if we did that, as you can see, is a capital T. So anytime you see a capital letter, it just means that there is no execute bit. And if I add the execute bit with the 777, and I do ls-l, as you can see, it's a lowercase t, which stands for sticky bit. And then remember, if I want to do set UID only, it's 4, and it'll be a lowercase s. As you can see, it's s. And you see the file, .txt turns red. So let's run the file command on it, and let's see what it says. You see, it tells you set UID is enabled when you read the file command. And let's say I wanted to enable all of them, right? Which is 7777. And if I do the file command, as you can see, it tells you sticky bit is enabled, set GID is enabled, and set UID is enabled. So all 3 of these fields or these special bits are enabled. So to go over it again, we do ls-l. If we enable all of them, you see S, S, T. T for sticky bit, S is for the set GID bit for the group, and then the set ID for the user, or I mean the owner of the file. But remember, if I do lowercase, which is 666, that means that only read and write execute for each field, it should be capital S, capital S, capital T. So as you can see here, this means that there's no execute bit. And the T means that there's no execute bit here. So anytime it's lowercase, then you know that there is a execute bit with it also. In addition to rewrite and execute, it also has a set UID bit in there. So remember, the first number is for the special permissions, if you ever see that. So the 4 is set UID, 2 is the set GID, and the 1 is sticky bit. So the way you want to look at the numbers is 4 for the first field, which is the owner of the file or the user, right? And then 2 is the group, and then 1 is for the sticky bit for others. So I mean, it's in the other field, So it's a little weird, but that's how it is in terms of the permissions and stuff. So we'll go over it real quick. So let me delete everything here. So we're going to remove everything. Okay. Okay, cool. So do you guys still have that file in your directory?
Which one?
Do you have like file1.txt or file text? If you don't, you can delete everything in your directory. We can start fresh.
Oh yeah. Okay. Fine. Okay. So delete everything. Okay.
Yeah, if you want. Yeah, we can just start fresh because I totally forgot if you guys had all those in there.
Okay. Good to go.
Okay. Is everyone else good to go?
Yes.
Yeah.
Yes.
Okay. Awesome. Okay, cool. So we're gonna touch a file.txt. And the only reason I emphasize this is because it's good naming convention. When you're writing your files, you want to know what it is for the next person. And then after we do the file, we'll run ls-l. And once you guys are there, just let me know.
Yep. There.
Yep.
Okay, cool. So I need a volunteer for the next one, which what we're gonna do, I need someone to tell me how would I change these permissions for file.txt to the following: to read, write, execute, read, write, and I'm gonna have to have, give me 1 second. Okay. And I would have to enable the set UID bit, the set GID bit. and the sticky bit. I want all of these enabled on this file. So pretty much this is what I need for this one. So I'm going to need read, write, execute, read, write, and then enable the special permissions, which is set UID, set GID, sticky bit, using the chmod command.
Nanaya, this your turn.
Give me a minute.
Okay, take your time.
I'm assigning myself as the class monitor. I'll be picking people going forward.
Perfect.
Okay, let me try it. So the RWX will be 776,
Correct.
and space with the bar set UID will be
So remember, where does the special permissions go? Does it go in the front or in the back?
In the front.
Okay, correct, in the front. Okay, so if you right now you want to enable the set UID and the set GID and the sticky bit, what would be the number representation?
okay. Where
Will it be 4?
No,
What, set UID? No.
no, because you set in everything. So it's set UID, set GID, and sticky bit. So you got to add all the numbers up.
7 will come in front of the 776.
Yes, yes.
Oh, okay.
Because remember, each number set UID is 4, set GID is 2,
2.
and sticky bit is 1.
1.
So in this case, he said you need to have all 3 of them on there. So you have 7 in front.
Got you.
In the case where he had just set UID and set GID, it would have been 6.
Mm.
If it was just sticky bit, it would have been 1
1.
in front. Yeah.
Perfect. Good. That was a good breakdown, Bath. Good job.
Okay, so the answer was you said what number did you say? What when you enable all of them?
Nanaya.
7.
Okay, beautiful. Yep, it's 7. And then let's do it on the file, and then we'll do ls-l. As we can see, you have all of them enabled. And what does the lowercase mean again? If you see a lowercase letter in the execute section.
Jeremy.
Say it again.
So if it's lowercase,
Yes,
execute is enabled.
correct. Great job. How about if it's uppercase, like at the end where the sticky bit is?
Kofi.
That means it's enabled or for the
No, that means there's no execute.
when it's uppercase?
Yes. Because remember, it was 6. It was chmod 776, right? So the 6 is for the other, which is it didn't have. It only had read write. The other could only read and write. You couldn't execute for the other.
Yeah, so just always look at it. Anytime you have a capital, a letter in any of those fields or in the last field, that means it's it doesn't have the executable permission assigned to that. If it's lowercase, that means they have both execution and also the bit that you assign to it.
Whether set GID or set UID or sticky bit.
Yeah. All right. So you could have a capital S or you could have a capital T.
Hmm.
And then
Right.
every time it's a capital, that means it's not executable. But if you have a lowercase, that means it's executable plus they have an additional permission assigned to it.
And if you look up, right, so not this one where we have the chmod on it, but prior to the chmod directive, you see how I think earlier Jeremy was able to explain the owner can read and write,
Mhm.
the group can read and write, and then the others can only read. If you look up there, you have to also understand those groups. Like the first three is the owner, the second being the group, and the third being the other.
Hmm.
Yeah, yeah. So if you understand it like that, it helps you. So in that case, how Prof has highlighted it, what's the number for it? What would be the number for it?
Would that be 664?
Correct. Yeah,
You got it.
yeah.
Okay. So I'll ask another quick question for the team. So, all right, let's do using the change mod command, right? How would I set the permissions equivalent to rewrite, execute, read, write, execute, read, write on the file .txt. Remember, when I'm typing here, is not the way you do it on the command. I'm just doing it a more of a transliteration. Like, you know how people speak different languages and then they translate it in like in a way that's understandable, but it's not the actual syntax. So just trying to make it explainable. So like what would you type in right here? Remember, these, you don't really type this in, but what would you type in here if I wanted to make it read, write, execute, and read, write? There's no special bits, special permissions in theirs. It's just regular permissions. So if I wanted to change file.txt to rewrite, execute, read, write, do I have any volunteers of how would you write a command? Yep.
We will give this one to Kofi again.
Would that be a 777? No, sorry, 776?
7 is correct and 6 is correct. Yes. So it'll be 776. So let's do it. Correct. 7. And then you have 6. Read, write. Beautiful. You got it. Okay. Okay. But what if I wanted to do the same thing? Right. But let's kick it up a notch. We're gonna do it with the actual with the symbolic meaning, not the numbers. So we'll do dash ls dash l, and then this time I want you to do the same thing, but I want read write, and then read write, and I want you to do it in the symbolic form that we went over. Remember, I can just tell you UGO is for user group and other, and then the permissions is RWX. That's the only hints I'll give for now. So how would you do it? Read, write on this file for the owner, the group, and everyone else on this file.txt. How would you do it using these letters? And remember your, yeah.
I'm gonna let Bav go first, and if he doesn't get it, I'll go.
Okay. So what do you want us to add to it? You want us to get?
Oh nope! I just want you to change your permissions. Read write for everybody, for the owner, group, and others.
Oh, okay. So would it be? I forgot what will come in front of it. Is it? So it will be you.
Yep.
And you want it to be rewrite u minus x.
You want to do u minus x?
Right, because you said it has to be rewrite, right?
Yeah, for everyone.
And then the next one will be g minus x.
Okay, I'll give you a little hint. So, yeah, so if you do it this way, if you see here, it won't work because it's only expecting one command here. So
Uh-huh.
to show you really quick, just an example, but I will ask this question later on. So
Oh, chmod. Yeah.
yeah, so if I did that, right, and then you do user group others, right? You can do, let's say you do rewrite. Correct? Hold on, give me 1 second. So file one, that text. So if I did ls-l, as you can see, it's rewrite. But the problem here is that I still have to minus the permissions for everyone to take out the X. So when you're doing this, right, it literally does what you're asking for. It doesn't modify anything. Like when I do this, if I do like let's say read write, right? So if I did 66, right, and I did ls-l, it literally does read write rewrite because it basically erases everything and it does it. So when you're doing it this way, it's just adding read and write. So if it has an execute bit, it'll still pertain it. Like it won't go away. It will still be there. You're just adding these bits. Like you're turning them on. You're just turning on read and you're turning it write and you're turning it on for others, group, and users or the owner. That's the only thing that's a little confusing about this command because we think about others as owner, but in this case, other is actually everyone else or others. Yep. So for this instance, as you saw earlier when I did the plus RW, you can do it multiple ways. It's not really a correct answer. It just depends on how many commands you want to do or however the case is. If you're doing rewrite on everyone, right, you can just do read write minus X on everybody. And then you can just plus rewrite on everyone. Because remember, this one's a lot more like literal. Like it's not resetting your permissions. Let me give you an example. Let me give you an example again. So if I did change mod 777, right? And if I actually forgot to finish it. And if I did ls-l, and let's say if I used change mod, right? And I wanted everyone to be read write only. And if I did user group and others, and I did plus read write on everything, and if I did ls-l, as you see, everyone still has execute because it's like it's like literal, like it doesn't do anything. It just turning, if it's already turned on, the command will execute, but it's not going to do anything because it's already on. So you could do, so this one's a couple more steps. Obviously, this wouldn't be the best way to use it. You'd want to use a numerical version because you only have to run it once. But in this case, was you have to run it a couple times to do it this way. So you're going to do minus. Actually, my bad. Now no one has permission. So, and then you can minus the execute bit on all the fields since all of them had it, and then just add read write to everybody. And if you do ls-l, hold on, give me 1 second. I'm freaking minusing everything plus. And then if we did ls-l, as you can see, everyone has read write. So that was almost like a little of a trick question because there will be multiple steps involved. But just to tell you the difference is that when you're running the chmod command, right? Change mod command, is that it's always better to do the numerical. It's a lot more like it resets, yeah, and it does everything. But if you want to change one person's permission, this is where you do that. So user group, and let's say you want to add the execute bit to it, you just add the execute bit to it. But the reason why it says that is because I forgot to add the file. But in this case, if I do ls-l, as you can see, I added the execute bit on this one.
Okay, so that will be for a single either user or group or
yeah. So the way this one works, you can do like this: user group other, and then rewrite execute.
Okay.
Yeah, like you can do like, let me see if the order makes a difference. I never tried it. I always do it conventionally. So it looks like it works. So it doesn't matter the order. It's all symbols.
Okay.
So so if you do like so remember the symbols, all you have to look at is just symbols. That's it. User group other, and then plus or minus. So you're taking away or you're adding the bits. That's all that means. And then the possible ones you have rewrite and execute. All right. But if we're talking about the special permissions, it's a little bit different of how it works. Okay. So when you're adding for special permissions, so if you do S, right? So let's say if I want to add a set UID bit for this, we did the numerical version. Remember, like the 777. Like if I want to do set UID, it's 477. So I remember that. So 4 is for the set UID. But if I want to use the numbering and stuff, I have to do user, which is the owner, and then plus S. This will enable the set UID bit. If I want to enable it for the set GID bit, is you change it for group. And if you want to add the sticky bit, you put for others and T. This one, you have to be a lot more specific. So if I did that, as you can see, the sticky bit's enabled. And if I want to minus the sticky bit, I just minus it from here. So if I try to, let's say if I try to add it on like user, let's see how that looks. It doesn't work. So if you use it the wrong way, as you can see, if I try to add a sticky bit for the user, ls-l, you don't get nothing.
All right.
So, yeah, you could also think you could try to do this to see if this works. I haven't tried this way. I always do everything conventional, but it looks like it added it. Okay, cool. So so the right side, it only applies the permissions if it's applicable. So like if you're adding a sticky bit on the user in the group, it won't work because it's only applicable on the others. So I guess like the script, the way the script was ran, it's smart enough to understand that, hey, if it's not others, then it's don't enable nothing. Like complete the command, but don't execute. The S, remember the S, as you can see, the S is here, is for the set UID and the set GID bit. And then the T is over here, and it's only for others. So when I ran this command, the UG applied this S command, and then when I ran the O plus, it applied the T, and the T didn't apply for these because there's no set UID on that one.
And then you have the capital S because for the other, I mean for the group, there was no execute.
Yes, as you can see here. Yep. No execute here. So you could also do like this. You can do like rewrite execute, and then I can have S on there, right? And then if I do ls-l, as you can see, I added the execute on everybody, like on user group and other, and then I added the S. So the S only applies at these two. So if I delete everything, oops, what am I doing? So if I remove everything, and then if I make that file again, and then if I do ls-l, and then I did change mod, and I said I did user group other, right? And then if I wanted to add read write, let's say I want to add execute. I don't have to do read and write because they already have read and write. So let's say I want to add execute to everybody, right? Then I'll do the execute bit. But what I can do is that I want to run only, basically, let me take the O out because I can leave the O. It's not going to make a difference. It's just like, it won't do anything. I can add it there, but to make it less confusing is that I'm adding the S, which means that I'm adding the special permission for set UID and set GID. So when I do that, and if I do ls-l, as you can see, they're uppercase because there's no execute bit. And if I did that again, I can run execute. Like I want to add the execute bit on those fields, and then they should be small. You see, because I'm adding for user and group, I want to add the execute bit because you see over here it's capital. There was nothing there when I added the set UID bit and the set GID bit. And over here, as you can see here, when I ran the user and group plus X, you can see over here that it added the execute bit for these two fields, and it also added the S. If I added the others on here, obviously we can see the execute bit will be on there because it's an execute bit. But if I added the S on there too, oops, that's the wrong way. It won't do anything because this is only the sticky bit. So for this one, I would have to add the T on there. I can do it. It wouldn't make a difference, but I can do it like this and then do ls-l. As you can see here, I added the sticky bit LT. So what we're going to do is let me do, so someone else now since we went over the command, I'll ask you for an example, see if you guys could do it. You can use multiple commands if you want, or however you feel like is the best way to solve it. So let me make a fresh file really quick. If you guys want to delete your file, RM with actual star to remove everything in your directory, and then you can touch the file again. That way we can start fresh because it's giving you the default permission from the system. So if all I'm going to ask somebody, once everything is set up, once you delete everything and make the new file, if you haven't done anything, you can just leave the file how it is. Like if you haven't change anything on it and it's been like untouched, then you can use the same file .txt that's in your directory now. But if you haven't, then you can just delete it if you want, or change the permissions, or however you want to do it. So for this one, we're going to use the symbolic version, which are the letters. We're not using any numbers at all. And your mission would be to add read, write, execute, and read, write. And then I would want you to add the set GID bit and the sticky bit. So for this file.txt, so we're going to add read, write, execute here, and then read, write, execute here, and then read, write here, and then add the set GID bit and the sticky bit using the following: UGO, plus or minus, and using the STRWWX. Trying to make it a little bit easier for you. So if anyone has wants to go, be free to answer this question.
Jeremy, you want to give it a try first?
Yeah, take your
Yeah,
time. Take your
I'll
time.
try.
You know,
I'll
no
try.
worries.
I'm gonna decipher it, and you guys
decipher it.
can assist me.
No, decipher it. Yeah. What I can do, I'm gonna do a Control C. Let me exit out of here, and I'll just type in exactly what you tell me to type in, and I'll just go along with it.
Okay.
And this is what you're trying to accomplish: rewrite, execute, read, write, and then adding the special permission or the special bit, the set GID, and the sticky bit.
Okay. So it's gonna be UGO plus so they need to be executed. So it's gonna be multiple, I'm assuming. So
Yes. Yep. I'll just type it as you go. I'll enter it, and then I'll do it again, and then I'll list
okay.
it. Yep.
Can we do UG plus?
UG plus. Okay.
X. So can I do SX?
Okay.
I'm not sure if that's possible.
Yep.
And enter.
Okay.
Oh, sorry, the file name, sorry.
No worries. Yep. I'm going to show you. I'm just listening to exactly what you're saying. I'm going to output it. That way you can troubleshoot it yourself. This is like more of an exercise. So ls-l. All right. This is what your outcome is now.
All right. So now I have read, write. I have the set GID and for that one. And then
Pause here really quick. It looks like over here you added the set UID in addition to the GUID. So you remember you did the user here, which is the owner.
other group.
Yep. So you added S on here also.
So it should have been
okay,
just
okay.
U plus SX.
Yep, that's fine. So how would we fix that?
Okay, so it's gonna be 1 second, G
Okay, so change mod G.
Minus hold on. Could use owner, G's group.
And then we do
And I just did the set GID
Yep, which
on both, right?
right.
You did
it both user and group. So the route that you are trying to go, I believe you need to take out the user one if you're trying to do the minus.
Oh yeah. Sorry. Because GID is for group and UID is for user.
Yes, you added the UID.
So so take off the G and add 1 second, U minus S and enter file.txt.
Okay, did it.
All right, ls-l.
Okay,
right.
looking a lot better.
Okay, 1 second. And the sticky bit is for everyone. So chmod
Okay.
o
Oh,
what does it have initially? Just read. So I need to add right and the sticky bit. So plus TW
okay.
Space file.txt. One second. Capital is with not execute. Okay, what was the expectation again? Is that right?
It was let me just remember it. It was add set GID,
Mm-hmm.
and then you want to add the sticky bit,
Mm-hmm.
and then I think it was read,
Read
write,
right,
execute. Was it read, write, rewrite,
read right.
and then rewrite, execute? Was it like this? You guys, do you remember?
Actually, no. It was read, write, execute, read,
right,
write, execute, read, write. Okay, so I need to
My
add the
bad.
execute.
Okay, we'll do that real quick. Yeah, I should have saved, copied and pasted it. So, okay. So far, what we have here, what it looks like, we have read, write, execute,
Mm-hmm.
rewrite, execute with the set GID bit, and then we
Mhm.
have read, write with the sticky bit. So far, it looks like this is correct. This side is correct. It looks
Mhm.
like this is correct. And it looks like that's correct too. I think
Am I missing the execute for the group or no?
you're missing the execute for the others, which is
Which is
normal
good.
because it's
Okay.
capital T. I think I think I messed up. I think I forgot to copy and paste what I literally did. Let me
Nah,
do
that one
okay.
didn't have the other didn't have execute. It was rewrite,
So she's right.
and then a sticky bit.
Okay, that's one. So it had rewrite here also, or was it all rewrite?
It was read, write, execute, and then read, write.
Like this.
Yeah, exactly how you have it.
Yeah, because this is read, write, no execute, read, write, execute, rewrite, execute. But oh yeah, this it looks like you have the permissions are correct. From what I'm looking at, set GID, set GID, sticky bit, sticky bit. The sticky bit didn't have any execute, which is none here. And then the execute here had has execute and it has the set GID. All right, let me do one more for you really quick. Let me just make it simple for
And
you.
before you do that, real quick question: how did the last command that she ran to set the sticky bit using the what's the name, the lettuce? What was the command?
Oh, so the
So
command is
chmod
Uh-huh.
O plus TW.
TW. I think I missed something. What was the TW for again?
No, the
Or-
T is for the sticky bit.
But the W?
The
Right.
W is for the right, because remember she had taken the right out. So
Okay. Yeah.
Okay,
that's
so yep, so I'm gonna go over it again. So remember U is for the owner or the first part, right? So you're changing this permission. The G is for the middle, and then O is for others. Sorry, that's a start 0. And then when you're place, you're adding and minusing, right? So plus or minus, so place or minus, and then you have read, write, execute, and then you have sticky bit. I'm sorry, sticky bit, and then you also have the set GID or the set UID. So we're gonna go over this really quick again. So let me delete the files here. And then this one should have read, write, or however the permission is. So we'll do ls-l again. I need to touch the file. Okay, as we can see here is read, write, and read. So remember here, what we have here, the user group other plus minus, read, write, execute, and then S and T. So if I am trying to change the permissions, let's say I want to enable the write bit on others, right? You would use change mod and then others plus X. So let's say if I want to add read to others, it won't do anything because it's already enabled. So the difference between the symbolic ones, it doesn't change, it doesn't reset nothing. It just adds it. So if it's already there, it's there. When you're doing the number version of it, like if I did like 777 on file, it'll actually modify everything for you. Like it will reset it and then just put the new number. If I did like 4444, you see it will delete the actual other ones. Like, because when you're doing it here, right, and you're adding a read, right here it's read, but remember it's also deleting the other fields with it. So when you're doing this, is almost you're resetting the file or the directory with the new permission. So if basically it has to be 444. Over here, if you're adding read, right, to it, it won't do nothing to it. If it's already enabled, it won't do nothing to it, and it won't delete the write or execute. So let me show you in the example in this one. So if I did change mod, and let's say if I did user group and other, and then let's say I want to add read write execute. All right. So for this one, I'll add it. But let's say if I want to add read write only, right? As you see, it doesn't delete the execute. It doesn't delete the execute. Like if I did this one, change mod, read write, like read write, which is 666. So read write on file one.txt. Capitals, okay. Come on, caps lock. Okay. So as you can see here, forget all this output here. Don't look at that. So you see on the top, change mod 666 dot file dot text. You see it actually resets it to read write. But when you're doing it here, when you have read write execute, read write execute, and you try to reset it here, it doesn't do nothing. It's adding the bits, but it's not changing it. Like the X doesn't get changed. It just adds those bits. And if it's already there, if X is already enabled, then read write is just adding read write. It's not deleting anything. But when you do the numerical version, it actually resets it exactly how you put it. So for this instance, I wanted to do that example that we did earlier, the change mod with the letters. So let's say I wanted to do read write execute, and then I wanted only execute on others. Go ahead.
Prof, what if you did UGO minus X? Would that make any difference?
Right now?
Yes.
So if you did UGO, no, it wouldn't do anything, but we'll do it. So if you did UGO file.txt, nope, doesn't do anything because it's already deleted.
Oh, because it was already deleted. Okay. But
yes.
if we didn't do the 666, would it have been would it have worked?
Yeah. So if you did let's say we
do chmod 777.
Yeah, it should add it for you. So if you do, yep, it should add the execute.
Right. And now we go UGO minus X.
Oh yeah, if you did UGO, yeah, now it'll do something. Yes. Yep.
Okay.
Because it does exactly what you ask it for.
Okay.
It's more like a granular control, more finer tuned control. So if we go back to ls-l, and let's say right now I want to do read write execute, read write, and then execute. I'm just putting random values. And let's say I want to enable sticky, and then the GID bit, or set GID. So set GID, right? I'm going to control C so we can see it for the example. You do change mod. As we can see here, the first one, it needs to execute. The second one, so the third one and the last one needs to execute. So what I'll do, I can do user and then other, and then I'll plus execute for now. Like you can do it different ways, but this is how I'll do it. And then you do ls-l, you can see it again. So I have execute here. As we can see here, that this is exactly how I want my permissions. So the first thing I'm going to focus on this, make sure that it's exactly how I want it. So right now we have read write execute, which is correct. We have read write and then execute only. So then I'll do change mod again, and I'm going to do others, and I'm going to minus read and write on it. Let's see. Read and write on file, and then ls-l. And now I see that we have read write execute. Nice. Read write, and then we have execute. Now I'll go for the set the special bits because it's going to be less confusing. I want to enable sticky bit and set GID. So I'm going to use group and others. And then I'm going to plus S and T. And the reason I'm doing this is because I can do it two ways. I can do it this way, or I can do it like this. G plus S. And then I can do another command and press O plus T. The only reason I'm doing it this way,
Sorry, what's G?
G is group.
Oh, sorry. Thank
Yep. The reason I do it this way is because a sticky bit doesn't exist in the group, in the set GID. So the S is for the GID, and for others is the sticky bit. So if I do it this way, it's not going to affect the other stuff. Like if it, like example, let's say, if I try to like basically you're trying to do something, I'm trying to do an action on something which is not possible. Like you can't do it. It won't work on it. You know what I mean? Like if you're trying to open the door that there's no door there, you're not going to open it because there's nothing that exists there. Like it's there, nothing. So you could do it this way. Like I said, you can do other plus a sticky bit, or I can do G. But conventional, the reason why I'm doing it this way is because I already know, like, when I execute this command, what it's doing is going to add this, it's going to add the set GID bit to group, no, add the sticky bit to T. And the reason I'll do it this way is because I want to do it faster and I don't want to run more than one command. But by convention, you can do it like this to make it easier. And if I do ls-l, we can see now that we have an S on there. And then now I want to do the sticky bit. So O plus T. And if I do this, we can see there's a sticky bit. And now if I read up here, read, write, execute, it's read, write, execute, correct? Read, write, read, write. And then I wanted to add the set GID so we can see the set GID is enabled. And we can see that now that's a capital S because there's no execute. And for the sticky bit, we just want to execute, which there's only execute. And we see the sticky bit's enabled because it's a lowercase. And if you want to check, we can do file command and then file.txt, and you can see what's enabled on this file, set GID and sticky bit.
So, Prof, what if instead of like using the lowercase, we use like the capitals, right? Would that have made a difference in that command?
I've not tried that before. Let me try that out. So let's try.
Right. Yeah.
So let's try on the group because the group has a capital T, as we can see. So let's see if we add a lowercase s, if it makes any difference. And then we'll do an uppercase. I don't think it makes any difference at all. Nope. So S doesn't work. So I guess like it's for the command is case sensitive.
Right.
And it looks like it doesn't work because it's enabled. It's only enabling the set GID bit. So since there's no execute bit, it won't change. It won't make it smaller because there's no execute bit on here. So all it's doing is just enabling the set GID bit.
Makes sense.
I have a question. You were just showing us the breakdown, right? But initially you could have done everything in one shot, correct? You could have just done like what was it? The UO plus ST
or TS. Yep, I could have done it like this. So if I do
G also,
yeah. Well, the reason why you would do it this way is because as long as you're okay with modifying the group and user, then it will be fine. But if you're doing it this way, sometimes you might modify another field that you might not want to modify. You only should do it if you are 100% sure that you don't mind modifying the other fields. Like yeah, and remember T won't happen to G. Like if I did since it doesn't, there's no sticky bit, so it wouldn't make a difference. So plus T, if I did that, as you can see, it's still the same. Yes. Yep.
Okay.
And if I wanted to do the numbers, right?
Yes.
In this case, for the GO plus TS, it would have been the chmod, and then what number? Like I guess for it's only a sticky bit and a SGID, so it'll be 3, right?
Yes, because you're adding 2 and you're adding 1. Yeah, so it'll be 3, and then it would be rewrite and execute, which was 7, and then read write, which is 6, and then execute, which is 1. So it'd be 461. The original one that I did So as you can see here is the same exact one.
Right. Okay. So what's the difference? What's the can we either way it works?
Either way it works. Okay, how about this? Make it easier. If you just want to modify one field, then you can use the change mod command.
Right.
Like you want to modify one or two fields. But this, when you're doing it this way, it resets the whole permission to exactly what you put in there. So yeah. So like example, let's say if I did change mod, right? I did 444 on file one dot text, right? And I did ls-l. The difference is let me just clear the screen so everyone can see. So the difference here is if I did this command here, you see 444, right? The difference is that it literally will change everything, even the special bit, and it will make it 444, meaning that there's only read, right? So when you do change mod, user group others, and you do plus RW, it literally adds read and write. So if all of these fields had execute, it won't change that. It will just add those bits.
Okay.
You know what I'm saying? This actually changes it exactly what you put in. And this one is just adding or minusing bits. This doesn't change. This doesn't change everything. So example, if I had, let's say if I had 777, I'll show you both examples. If I did 777 and I did ls-l, you can see rewrite and execute. If I did 444, as you can see, it actually, let me do 444. I'm going to do ls-l. So as you can see here, it actually changed everything. When I did 777, it did this, and then this changed everything. Now we'll go back to 777, ls-l. Now we do the user group, right? And then we're going to do plus read write. Let's say we only want read write only. This doesn't take away the execute, as you can see. All this does is minuses or adds bits to where you want it. So this is more like granular. This is more like you have to be specific. Like, hey, you know what? I want you to add read write, and then I want you to minus X on all of them.
Okay.
You would have to be a lot more like granular. Actually, I'm sorry. You want it only read on there. So what we can do is we can do minus read and write. So yeah, you just have to be more exact with this command. It's more like granular control, like more fine tuning.
Okay.
Yeah. All right. Is there anything that anyone doesn't understand, or do you guys feel like you understand the concept a lot more in terms of the permissions and this? So we have the permissions, which is the read, write, execute. And then we also have the special permissions, which are set UID, set GID, and the sticky bits.
Yeah, you did a great explanation of everything today. I liked it.
Yeah.
So with the numbers, it don't allow you to be able to use the UGO minus or the plus to add to it or take away. It changed it completely if you use that. Okay.
Yeah, if you use the numbers completely. So let's go to the man pages. I have to put this in one of our assembly to use the man pages, but we'll look into the command real quick and it'll give you more details. So if we're going here, it says the mode. So you see the mode. So when you see in the mode, these are like the actual like numbers, like the actual like letters, like, you know, the letters that you're putting in. And then if you see the octal, these are like the 777, 111, whatever it is. So if we go here, it says the format of a symbolic is UGO. It says a combination of letters controls which users access to the file. So like user group others. And I think what's A for? A is for all users. Okay, so I haven't used that before. I haven't read this in a while, but it looks like you can use A also. So let's try that. It says you can use A. So we'll do ls-l, and then we're going to do A, and then we're going to plus execute on everyone. So actually, I forgot to put change mod. Command not found. Okay, so ls-l. As you can see, if you use the A, it references all of them. So A is for all, which is said in the documentation. So instead of using UGO, you can use just the letter A.
Gotcha. Oh, okay. Definitely learned a whole bunch of things. Okay.
Yeah.
All right. Nice, 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 nice.
Yep.
Nice. Like that. Okay.
So, if you guys are willing, I can go on and explain the access control list. If you guys want to do that, it shouldn't be too much. It's like just two commands, and that's pretty much it.
Okay.
Okay, because this will be the final part, and this will finish the permissions part pretty much for you guys.
And we
That's
should
it.
be able to handle the homework with what we learned today, right?
Yeah, you guys should 100% handle the homework. I'm gonna adjust it a little bit, so give me like 30 minutes, an hour. I just want to add some stuff that I think you guys will like in there
Okay.
for the homeworks and stuff.
So
Okay.
in terms of the
Yep.
Linux file permissions, you said this will with the next one that you about to do. But are we gonna also be learning about the chown and chain
Yeah,
group
well,
and all those things?
yeah, well, add on the other ones. I was like, this one is more like I wanted to. I'll add the change owner and all that, but this was more like learning the actual like permissions and like I was just more focused on the permissions, like getting like a base foundation, and then the change owner
Okay.
isn't. We'll go over that too if you guys want. We can go over that today. It's not too bad. It's like change owner is very simple. So there's a couple of them. There's change owner. There's change group also. So I'll show you what that is really quick. So change owner, all it does is just change the owner of the file to the directory. So if we do chown, you can do change owner. Let me look at the directory. I mean the syntax. So first is Tom, so change owner Tom. Actually, I don't want to change it to Tom. Let's change it to. Let me add another user, really quick. Sorry about that. So I guess sudo. What was my password? Give me 1 second. I totally forgot.
1, 2, 3, 4.
Yeah, I think I changed it again. I totally forgot about it, even write it down. Not a big deal. I can always change it. So let's do user add is locked. Okay, there it is. Okay, so let me exit out this user. Okay, so if I think I still have to use what do you call it, sudo. So we'll do ls-l. So let's say I want to change the owner of this file from Tom to Sally. So I'm going to do, forgot the syntax of it. Let me check the syntax of it really quick, you guys. So chown help, help. I'm gonna go scroll to the top, make sure I'm doing it correct. So it's change owner, and then you do the owner, and then colon group, and then file. Got it. Okay, so I'll explain that to you guys. So the way you guys, how you do it to change the owner, you do change owner, Tom, and then I want to change it to Sally, and then I want to change file.txt. Then put sudo is not allowing me to do it because I don't have sudo permissions. Okay, I guess I'll have to do it with another one because Tom doesn't have enough permissions. So let me do it with let me try with Professor Linux. What? Oh, so I get a permission on there too. Yeah, I made this on purpose, so I didn't do anything crazy. So let me just change it to Professor Linux. I'll just do it from here to do those commands. So is that the correct one? Okay. Let me do CD. Cool. So let me change the Tom's home folder. What? Are you serious? I guess I didn't give myself enough permissions. So let me just go to. Okay, cool. All right, we can do that now. Do CD. Cool. CDs to Tom's folder. Okay. So if I do ls-l here, as you guys can see here, now if we do the change owner, we can change owner to from Tom to Sally on file 1.txt. And if I do ls-l, as you can see now, oh, okay, I see. This is the group one. Got it. Okay. I didn't read that part of it. Okay, so the second part here changes the group, which there's another command like change group or something. So let's leave it to Tom. Let's leave this to Tom. So I'm going to change this file to Sally. You don't have to do the colon. I think the colon is if you want to change the group too. So we'll change this. We'll change this one to Sally. Let me put Tom here really quick to make it easier for you guys to look at it. Sorry about that. So as you can see here, So the first part just changes the owner of the file, and the second part changes the group. So when I did this colon, it actually changed the second part to the group and the first part to the owner. But if you just want to change the owner, all you have to do is just type in the new owner, which is going to change right here where I'm highlighting where Sally is. So that will change it to Tom. So if I do that, as you can see, it changes the owner to Tom. And let's say if I want to change the group to Sally, I can just put the colon and leave the front empty. And the reason I'm leaving it empty is because I don't want to put anything there. Like I don't want to like change the owner. I just want to change the group. You can do change own. And then if you do ls-l, you see I only changed the actual group of that one. If I want to change the group again, I can put the colon in the front and put Tom. If I do ls-l, as you can see now, it's Tom because I changed the actual the group back to Tom. And let's say if I want to change everything to Professor Linux, and then if I want to change the last part to Professor Linux, I would have to do this, change owner. I want to change the actual owner, and I want to change the group of the file. I think I spelled that one wrong. Yep. And if I do ls-l, you see Professor Linux now is the owner and file. And then if I want to switch it back to Tom, but let's say I just want Tom to be the owner of the file again. He's the owner, but he's not part of the group. So if I want to change the group by itself, I can just do the colon and do Tom. And if you do ls-l, it's back to Tom. And then you can also do change group is something similar to this. So let me see if I can use change group also. It seems like change owner is sufficient enough, but let's look at change group. Change group ownership, group and file. So we can do ls-l and then change group. Let's change the group from to Sally for file one.txt. And if I did ls-l, as you can see, Sally is now the group for this, or the group for this file has changed. So you have change owner, which you can change the actual user, and then group. And if you just want to change the group, you just do it like this. If you want to change the owner, you just do it like this, like on its own without any other things. And if you want to change the group by itself and you just want to use this command, you can do it like this too, and then add the file that you want to change. Change owner, you have to remember to put the colon to delineate that you want to do the group after this. Does that make any sense, you guys?
A little bit.
Yeah.
A little bit.
Okay, sorry.
I think I don't know if because it's the end of the class, I think it was moving very fast for me, and my mind was just all over
Sorry,
the place.
let me explain really quick. So all the files and directories have an assigned user, like so it has an assigned like owner of the file. So like Tom is the owner of the file, and Sally is the group or the group owner. So this is the group that owns this file, and this is the owner that owns it. So
Right.
you might have like Tom made me own the file, but the developers group might own this also. So all you're doing is just changing the owner of the file. So let's say like you made a file called file text. Tom made it, but let's say I want to change it to a guy named Gerald. I'm going to change it. I'm going to change the owner to Gerald. If I want to change it to, let's say, change it to David, then all I have to do is do change owner, because I don't want the owner to be Tom no more. I want the owner to be Sally for this instance. I'll do file.txt. And if I do ls-l, we can see now the new owner is Sally. Is no longer Tom. Sally is a new owner. But let's say I change my mind. Hey, you know what? I don't want Sally to be the owner of this file. I want Tom to be the owner. And if you do this, if you do the ls-l, that means Tom is the owner. So remember, these permissions here is for the owner, right? So when you switch it to the new owner inherits this permissions.
Okay.
So like if Tom was the owner and he had read and execute permissions, so let me make it simple for you. Let me make another one. I'm going to do 7. Let's do change mod 700 on file that text. And if I do ls-l.
But to do that, not to cut you off,
No problem.
to do that, you have to be in root to do that. Those for
You would have
chown
to.
and
Well, you as long as you're like, if you can modify your suitors file or have special permissions, you're able to do it. But yeah, you would have to have elevated privileges to be
Okay.
changing. Yeah, because if you think
Okay.
about it, if I'm just a regular user, I can't assign like, you can't just change other people's stuff. Like you would just, yeah, you would have to be root or have some special privileges or be part of the suitors or the wheel group to do that.
So that's why you, before you did all that, you went and changed all, because because right now I'm at time, so I can't do this whilst I'm at time. I got to change back to the root, right?
You would have to be root, yeah.
Okay.
You would have to be the root user just because you're changing files and permissions and stuff like that. I think if you're part of the wheel group, you can. Let me see if I can add professor. Let me see if I can add Tom to the wheel group. So I think it's user mod. We'll go over this in next class. So let's switch to Tom. Yeah, I think it's the wheel group. I'll try that later so I don't spend too much of your time. But we'll go over the next one. I'm going to see if the wheel group does allow it, because usually wheel does give you more permissions and stuff to do it. But I'm not exactly sure because you have like, basically there's a file called suitors where you can like modify the file and you give certain like users certain permissions to do certain things on your system. So but yeah, that's the reason why I changed the root is so it lets me change it. Okay. So yeah, so in this instance, you guys, when we went over this real quick, before we go to the access control real quick with you guys, as you can see, we have read, write, and execute. But let's say Tom is the owner, so let's change it back to default, where Tom was also the group too. Okay, ls-l. As we can see here, Tom is the owner, right? And then this is the group owner. So this group owns this file. So as you can see here, this is for the group. So whoever's part of the Tom group has those permissions too. You see what I'm saying? So if I change the owner to Sally, right? That means that right now, now Sally inherited the permissions of read, write, and execute on this file, right? But since Tom is still part of the group, that means the user Tom. So every user, when they're made, like Sally is made, Tom is made, David is made. When they're made, the group is created with their name. So in this instance, that means that Sally has these permissions because she's the owner of the file. But the group is Tom. So that means since Tom is part of the Tom group, he has no permissions right now. But if there was permissions, that means he'll be able to access this file. So essentially, when I change the owner of the file, these permissions get inherited by the new owner and the new group owner. So okay. now Sally has read, write, and execute permissions. Tom doesn't have any permissions now, even though he's the one who made the file. Like Tom made the file, but let's say I fired him, right? And he's no longer with the company. And that script, now I want Sally to maintain it. So what I'll do, I'll change Sally I'll change Sally as the new owner of the file and also the group owner of the file too. So if I do ls-l, you can see now I changed the file. Now who owns the file is Sally. Because let's say that person got fired, no one will be able to access it or have the special permission. So you can also change the owner of the file. So change owner, all you're doing is just changing the person who owns the file. And then when you're changing the group, you're just changing the group who owns that file too. That's it. So example, give you one last example that will make even more sense for you guys. So let's say you have a directory, right? And that directory is a developer's directory, right? Let's say you have many users, Tom, David, John, Lucas, right? And all of them are going to have this field change with their name. One might be Sally, one might be Lucas, one might be Tom, one might be David, one might be, Jerry, right? But guess what? At the end, since they're in the developers group, all of them will have developers. All the group will be under developers. So when you're changing the group, that means that whoever's part of the group is allowed to do modifications. So if the group had read, write, and execute, that means if you're part of that group, you can do those modifications on the actual file. So in this instance, since if I'm not part of the Tom group, no, if I'm part of the Tom group, that means that I have no rewrite and execute. And if I'm not the owner, which is Sally, that means I don't have rewrite and execute because everyone else doesn't have rewrite and execute. The group doesn't have rewrite and execute. Only person who has rewrite and execute permission is Sally. So Sally is the only one that's able to do anything with this file because I changed the ownership from Sally to Tom. And if I did, let's say, let's do group add, admin. And then now if I do ls-l, we can do change owner. And then I want to change the group to the admin group. Now I want this to be part of the admin group. And if I did ls-l, as you can see now, the admin group owns this file also. So the admin group, whatever permissions are in the group section, that's what the group has. This is the permission what the group has. And for Sally, there's the permission that Sally has. So Sally has rewrite and execute. The admin group has no permission here at all. And then everybody else has no permissions also.
And then while we on this, can you also like touch on, because I think it will maybe shed a little bit more light on it too.
Yes.
Touch on adding users to that, like the group also. I'm not sure if we went over that.
No, we're gonna go over that next one just because there's a lot more commands.
Okay.
So yeah, we'll go over that. This will be like this was just part of like because you want to go over the ownership. I was gonna go over this the next class, the ownership and the groups and how to make groups, how to delete groups, user, home directories, all that stuff. But I just wanted to shine light since he was mentioning it, and I just wanted to tell you what it was. But I do we'll go over the set facal. Should be like 10-minute overview. And then I can explain it more in detail. But remember, change owner, you're just changing changing the owner of the file or the directory, or changing the group of the folder or the directory. That's all you're doing. That's what change owner does. You're just changing the owner, whoever owns the file. All right, but we'll go over the change owner and the change group more on the next one, and I will show you guys a lot more examples and stuff. But yeah. Okay. Hopefully gave you a little bit of insight, at least a little something that makes a little sense. But trust me, this will all be put together over time. Like over time, it will make a lot more sense. The more you use Linux, the more you play around with it, and it will start bending together.
Okay.
And I think, but if you stuck on the two last commands,
the change owner.
Oh yeah, I was asking about if he's stuck on it, because to me, I think that those are like the easiest one in a way.
Yeah, they're pretty simple.
You were able to get file permissions, and you get stuck on this one.
Yeah.
Like I said, I think it's because it's the end of the day, and my mind is just but I'll get it. Like he said, it will all come together. So I'll review it again. So no problem. And next week when we go over it,
we'll go over it too. And just to let you know, remember, change owner means change file owner and group. So you don't have to do group. It's optional. I'll teach you how to read this because there's a way to read these. But right here, remember how I did owner? So if you do owner on its own, it can change the owner of the file. If I do the colon in the middle and then do group, that's why you see the colon like that. You see, that's why he's doing that. Sorry about that. It's doing that because it's saying if you just want to change the group, you have to add the colon, then the group. That's why it's like that. The brackets and stuff. But either way, the whole point of this is that it just changes the owner and the group of the file, or only the group or only the owner if you like. That's all it does. Yep, and it says here, change own performs the same function as change group. Remember the change group command I showed you? So this command does both.
Okay.
Yep. All right, and we're gonna go over facals really quick. And the reason why I wanted to go over this real quick, so there's two main commands, which will be get facal. So what get facal is get the access control. So if we go over the man pages and we look at the definition, we can see get file access control lists. And the reason why you would use this is because
quickly, I think Jervy got kicked out, and I think she's trying to come back in.
Oh, sorry about that. My apologies. Yeah, because I have another screen that's open. I didn't see it. It's like right in my peripheral.
Recording in progress.
We'll just wait for her to log in.
I'm here.
Awesome. Okay, so we're just started just now about file access control list. So in order to get the file access control list, as over here we see ls-l, we can see that this is the regular file, this is the regular file. We can see that the directory, right? Remember what we went over in the beginning? We can see the permissions, right? And all that. And you see the little period. Remember that period just means that it has regular permissions. Nothing special. That means that there's no access control list, right? So if we do get facle, right, on file one.txt, we can see here that it gives you the file access control list, right? So it tells you, so you see the little, there's a little comment pretty much. So it's telling you the owner is root, the group is root, the name of the file is file one.txt, and then these are the permissions: read, write, read, and other. And if you go here, it matches everything. As you can see, file one.txt is file one.txt. Root is root. User is read write. Group is read, and other is read. All right. Does everyone understand that concept? When you run this command, it just shows you the output of the ls-l command pretty much on a specific file.
Okay.
Okay. All right. Just remember when you run get facle, it's just telling you the permissions of a file or directory that you're running it against. That's it.
Okay.
Okay. And the reason why you run this file is because let's say you want a user to have permissions, right? Let's say you're in a developer's team, right? And there's a file there that you want him to have access to be able to edit it and do stuff, but you don't want him to have access to the whole group. You don't want him to have access to the whole group or anything like that. You use file access control list to give him a special access to it. So that's what access control list does. It just gives you can change, like, you can be more specific in the permissions you give. So instead of giving him permission to the whole group's file, you're giving him access to one specific file. And the way you would do this is that I can do set facle. So the set facle command basically is when you're setting the actual command itself for set facle. So if you want to, let's say you want to give him a certain permissions for a certain file system, you would have to do it this way. So it'll be M for modify. So we'll go here. So it'll be M for modify. So this will modify the actual file for you. And then let's say you want to change the permissions for it. So let's say you want to give Tom, and you want to give him read, write, execute. So we can do read, write, execute on this file. As you can see here, since Tom is not part of the root files, since Tom isn't part of the group, or Tom isn't root, so Tom isn't root and Tom isn't part of the root group, you want to give him rewrite execute. And the reason why you're doing that is because everyone else can only read, right? No one can write it, no one can execute it. So when you give Tom this permission, only Tom is able to do read, write, execute, right? On this actual file, because he's not part of the root, and root only has read, and the root only has read and write on this one. Technically speaking, you can root changes all permissions if it can, but it won't be able to execute it unless root changes its own permission back. But just for showcasing it, M just modifies it. All right. So if we're modifying it, we'll do file one.txt. And if we do get facle again, as we can see now, the difference is here is that we can see that we have user here. You see user, and then we have the mask. So there's the mask on there. So it's basically telling you that there's a read, write, execute on here, which is from Tom. So now we see Tom has rewrite and execute. And if we do ls-l, you can see a plus. You see that plus? That just means that there's an access control list enabled. So when you see that plus, that means there's an additional permission to it. So all we did here, this is pretty much this is the last command that I was going to show you guys, is set facle. So set facle sets the command. Get facle gets you the information about the file access control list. So all I did here is that I gave Tom, the user, rewrite and execute permission on file one.txt. That's all I did. In M, all that did was modify the file for me. And if I want to delete it,
I was just about to ask that.
Yep.
Okay.
Yep, you can use the X. X removes it. So X should remove it. I think is it a capital X or let me see. There's a certain. Nope. Give me 1 second.
What did you say get Falco does?
So get faco just gives you the file access control list on the actual one. So as you can see here, sorry.
And then the set Falco, it says command.
So
Yes. So
that Falco sets the file permissions for a specific user for a specific file. So if let's say I created a file and I want to just grant just you access to that file, I can use the set Falco to just give you the read, write, and execute whatever permissions you want to give just for you alone.
Okay.
And then the get Falco is used to retrieve all the file permissions that's associated with that, or the fine-tuned permissions that's associated with that file. So whatever file permissions I just gave you, I can use the get Falco and the name of the file to retrieve those permissions to see who else might have access to it.
Okay.
okay.
Yeah, cool.
So I think for this one, I think there's another field that I need to put in there. So give me 1 moment. I think I have to put the user in front of it. This is a little bit different, but let me try this out. Man, set faco. Double check this really quick. So we have the set faco command, and then we have either M or X. I think X is for deleting, and then the file, and then I guess where's the person? I don't see it here. Let me just go down real quick. So this is where you usually want to go if the syntax isn't correct. So sometimes the syntax isn't correct. This tells you how to use it here. So we have the default, which if you want to make we'll go over this next time too. Let me add this to my note real quick because I don't want to run out of time. Add this to my note. Give me 1 second. Explain default for the next class, and then also change owner. Okay, cool. We'll go over that one. Okay, so over here is just telling me how to use the actual command. So you have the user. Is it a user or what is it? Is it a group, whatever? So it's the user, which is you. And then we have the UID, the user ID, and then permissions of a named user, permission of the file owner if UID is empty. Okay, got it. And then on the permissions. Okay, so let's try that out. So set to faco. Then we're gonna try X. And then let's try you, and then Tom. And then let's try to minus, was it rewrite execute? Let's say invalid option X, invalid argument near character 7, which should be 1, 2, 3, 4, 5, 6, 7, which is the last one. It's not letting me work on this one. This is weird. Let me try the M. I know the M will work, should work. Okay, M does work. Why isn't it deleting it? Let me try ls-l. Give me 1 second. Get faco. So when we added this, it didn't do anything because we already had these permissions enabled. But executing is usually with X. It's been a while since I used this exact syntax that it shows. But I can go over the next class, see why it's not deleting it the way it should, because X is what is for deleting. I think I need to be more specific, maybe. So U is for user. We got Tom, and then we got rewrite execute. So removing everything on here. That's weird. Anyways, essentially, the -X should be removing it. I'm going to go over the syntax and just make sure that I'm writing it correctly. Or writing it correctly, And when you're doing the M flag just means that you're modifying it. So you're pretty much just adding the permissions that you want. And then the -X is supposed to be deleting or removing any of the any of the files that you don't want, or any of the access control that you don't want enabled on the file.
I just
So-
did like a quick Google. Instead of X, let's try the -D.
I think the -D is for default. So if you did,
Oh.
yeah, so -D, what -D does. Oh, so let me show you what -D. So I'll go over it. It might be one, sometimes it's like the way the command is very, very exact. So if you like do it in a little different way, it doesn't work at all. But so the -D, what the -D flag does for set facle, if I have if I have a folder named admin, right? What that means is that when I set the directory, let's say if I give Tom access to file1.txt, right? Tom will have access to this file. But if I do it, if I do the D, if I do a default on the admin directory, that means that every single file that's created in that directory by default will have that access control list. So it'll give Tom access to all those files, right? So when you do -D, all that means is that anything that's created in that directory by default will have Tom, or will have those access control lists enabled. Because usually, if let's say if I made let's say if I didn't have any access control lists on the admin folder, every single file afterwards, like file.2, if it's created by somebody, is going to have normal permissions. File 3, yeah, will have normal permissions. But if you put the -D on this folder, whatever access control list that you enabled under with the -D, like if I did, like let's say let's do ls right here, and I can see images in one. If I did set facle -m or d/m, and I did like Tom has rewrite execute permissions on the images directory, right? If I did this and I did get facle, and I did get facle on images, right? As you can see here, the default now. So you can see the default. So that means now every single thing that's made under the images, it'll inherit the access control list as a default. That's all that means. Yeah. I'm not sure. Yeah, no problem. So the set facle and access control list is very simple. There's only two commands: set facle to set it, get facle to get it. To delete it is -X, but I don't know why it's not working. Maybe I'm adding an extra field. So let's try to do this. Let's try to do a -X. Yeah, it doesn't make sense because this is how I've done it in the past. So I'm not sure if I mess something up or why it's not working correctly. I'll have to look into that deeper. But -X is usually to remove stuff, or maybe let me try capital X because I know there's two versions of it. No file such. Oh, let me see ls-l. It's in the same directory. Okay, well, all right, doesn't matter. We'll probably go over it next time. I'll look into this error and try to get that fixed for you guys. But remember, access control list you got is for being able to add specific permissions to people for specific objects and stuff. And if you want to delete permissions is -X, but I want to go over it on the next one just to see why it's not doing it. Let me try one more time. User, and then we got Tom, and then rewrite execute, which is the file. No, it didn't like that before. Yeah, it doesn't make sense. It's not invalid argument, so this is exactly how it's supposed to be. It's the weirdest thing I've seen. It's not even telling you what's wrong with it, but yeah, that's it. I'll put some homework on for you guys. The set facle, I'm not going to put any homework just because there's some issues with trying to delete it. So we'll go over that the next time. And,
okay.
Yeah. So if you go over here, you can see here the -X is to remove, and the capital X is to remove file options, remove access control entries. It is not an error to remove an entry which does not exist. Only ACL entry with the permissions field are accepted as parameters. Yeah. See, you see how we did it here? Here's an example. As you can see here, set facle -X. You see G, because you're trying to do the group, and then staff, and then the file. So this is enabling it for the group, but this is how you're supposed to do it. So I'll put you, and then I put Tom. Let me try that. Just user and Tom.
Can you clear the page so we can?
Oh yeah, yep. Let me do that. I'm not sure. I don't think it's supposed to be like this, but yeah, see, because the next command that is looking for is for the file of the directory. So let's try Tom. Yeah, doesn't work. So we'll try users. Doesn't make sense. That wouldn't make any sense.
What if
Okay.
you remove the read, write, and execute?
Yeah, if I'm trying to remove the with the minus x, which is, let me do /x, and then I'm gonna look for the options here. The best way to troubleshoot stuff is by actually getting issues. So removing a named group entry under file. But if I do user, which is the group, I mean the user is the user, and then Tom should be the actual name, and then file is the name of the file. So this is exactly how you use it. So here, generating an additional user access -m, that's what we did. We did this, but when you're deleting it, it's basically the same thing. But it doesn't work. There's something, oh, maybe revoke and write access for all groups and all named users using the effective mask. Oh, it's masking it. Okay, I see. Well, that's another video that our lesson that we'll go over. Okay, I'll look into this. I'll put this in my lesson plan for next time to see why we're getting that execute error. But so the homework is pretty much going to go over all the permissions that we did, the rewrite and execute for the numbers, the symbolic versions of it, and then the numerical versions, and then so there's going to be a lot of tests around the permission stuff. And then also there's a special bit, the set UID, set GID bit, and the sticky bits. And then the next class, in the beginning of it, we'll go over the set FACL and why it wasn't working. And then I'll add that to the next homework as an additional homework. So you can play around with it and stuff like that. And then I'll also go over the set owner and the set group for the next one to explain it a little bit more in detail. And then next class will be like administration stuff. So like learning more about like the, the making users, making groups, deleting groups, adding and modifying users, like getting, like, if you want to block a user from logging in, how do you do that? Their password, like their password credentials, like how to like have it so like every 7 days it gets updated, or every 30 days or 60 days they have to update their password. So pretty much the next class is all about user and group management, adding, deleting, creating, modifying, all those things that entail that. And then the next class will also go of like, we'll actually set up a lab where we'll have like the users in a folder, and using these bits, the set GID bit, and making a folder and seeing how making a file in that directory will get inherited by the group. And then we'll do the sticky bit without the sticky bit to see if you can delete other users. And then we'll enable the sticky bit to kind of show you guys how it's done in more of a production environment of how it'll look like.
Perfect.
Okay.
Thanks.
And yep, no problem.
Excited.
I'm excited too. So I'm gonna try to think of I think I'm gonna send you guys the script maybe, and it's just set up the environment for you, so I can just write that script, try to get that done. So it'll be something very simple. I'm gonna try to see how I can get that going for the next class, because it'll be pretty cool to kind of see some things in action. But that's
Okay.
it. Is there any questions at all about this class? Any other permission stuff other than the set FACL? We know what set FACL does. You can modify stuff, but the removing part will go over it. And the get FACL, remember, tells you about the extended permissions on there. And then remember the plus. When you see plus, that means there's access control list on it. And if you see the period, it's just regular permissions on there.
All right.
Okay.
Yes. All right. All right. Well, have a great day, everyone. I'll be, as soon as this video is done processing, I'll upload it to the same OneDrive and then post a link in the actual WhatsApp chat or in the notes chat. And I'll update the homework. So give me like a couple of hours. Tomorrow morning will be best if you guys look at the homework. I just want to make sure I get a lot of cool stuff in there.
Yeah, take your time.
Yeah.
We usually like tackle it like sometime during the week. So take your time.
Okay. Yep. I should have it done by tomorrow morning then. Have all the permissions and all that cool exercises you guys should have and go through.
Right.
Okay.
and stuff
Thank
like
you
that.
so much.
Yeah, today's class was very insightful.
Yeah.
Yep. I appreciate it, you guys. Hopefully you guys feel more comfortable and looking at the Linux command line files and stuff.
I think they get in there because even
Yeah.
like from day one to where even just me listening in today, I could tell everybody's getting a lot comfortable. So which is good.
Yeah, that's why I want to go over all the basic stuff and understanding, because the root stuff is very important, because when I go into other stuff, like it's not going to make any sense. Like it all is going to be gibberish. So
Right.
like understanding this will definitely help out, especially when we start setting up like network file shares, and I can show you guys how to. We'll talk about that, what it is. But when we're setting up we'll have like 2 virtual machines or like 2 instances, and then we'll be configuring stuff. And I'll show you how you can share files and stuff. But later on. But before we even get there, we're gonna learn a lot about the basics and stuff. So yeah.
Nice.
Thank you.
Okay, cool. All right, you guys have a great day. If you have any questions, please don't hesitate to reach out.
Will do.
You got it.
Thank you so much.
All right, you're welcome.
Bye.
Have a good day.
Bye-bye.
Bye.